Yes, speaker is turned on.
聞こえますか？
I think they didn't turn on the speaker. Because our speaker is like working pretty well. Yeah.
聞こえますか？
聞こえますか？We can hear you. It's on. Like, logging again? No. But camera is working well and speaker is also like working well. No. This is the handle meeting like we are using now.
Change the mic?
No, it's a
今聞こえます。
聞こえますか？
hi. I'm gonna share the screen. 画面見えますか？
はい、大丈夫です。
大丈夫ですか？はい。
いなくなったわ。始めていいんだよね、会話。20分で。
大孫シンドローム。
Okay, can you hear my voice? Taiwan side?
Yes, we can hear you.
Okay, is it no problem to start class?
Yes, please go ahead.
Okay, thank you. Okay, so let's start my class. So today's my class title is Food Poisoning and its prevention measures. So the about 3 around 3 hours, including the 15 minutes rest. First, so let's introduce myself briefly. So my name is Utsumi. So I'm professor of the Faculty of Life and Environmental Sciences, University of Tsukuba. And my study field mainly is aquatic eco-engineering and also the microbiology, especially the environmental microbiology. So it's not closely related to today's half topics, food poisoning. But now the food poisoning main cause by the microorganisms. So the related microorganisms is very important, not only the environment, but also the food and food poisoning or fermentations. So this today's my class, I want to introduce some information, not only the food poisoning, but also the microorganisms, and also the water. So water is very important resource for human beings. So and my measure is closely related water and water qualities So today's my class topics is about three. So first is water, second is microorganisms, and third is food poisoning. And my study topic recently microbial processes related to the biodegradation of contaminants in aquatic environments. Also, the quantifying the bioavailability of dissolved organic matter, such as dissolved organic carbon, methane, nitrogen, or phosphate. Also, now it's very difficult to go abroad by myself. But 5 or 10 years ago, I many times went to abroad, especially the Arctic regions, because I want to study bacterial production and community structure at the Arctic Ocean and Arctic terrestrial regions. But anyway, so today's topic, water, microorganisms, and also the food poisoning. Okay. So at first, water. So what is water? So water is essential for life. You can live for 40 days, about 40 days without food. But if you don't have drinkable water, you cannot alive less than 5 days, basically around 3 days. That means 72 hours. So I think you can, some fear here. So some kind of the emergency. So earthquake or some things. The rescue limit for human is basically 72 hours. That is 3 days. Why? Because human beings cannot survive if they cannot get drinkable water at all. So this 3 days, 72 hours is very, very important. But more important is we should take drinkable water. That means fresh water. That's very important. A human being requires at least 20 liter drinkable water per day. Okay. So second important point is the amount of fresh water on the earth is limited, and its quality is under constant pressure. And preserving the quality of fresh water is important for the drinking water supply, food production, and recreational water use. But water quality can be compromised by the presence of infectious agents, toxic chemicals, and radiological hazards. A second important point, what is water, is here. So water is one of the most important country resources. If some country doesn't have enough fresh water, drinkable water, it's very difficult to manage the government or the countries. So the fresh water source is very, very important country resources. I think some of your mother country is severe problems of the drinkable water, but water is essential, required for human being survival. Okay. So already some global leader mentioned water importance. So first one is Islam Sergeldo, who is a World Bank Vice President. So he said, so if the war of this century means the 20th, last century, fought over oil. The wars of the next century means this century, 21st century, will be fought over water. Unless we change our approach to managing this precious and vital resource. And Gary, who was the United Nations Secretary General last century, so he also told the next war in the Middle East will be for over water, not politics. So this word is some aspect right, but some aspect not right, not correct. So now the Israel and Hamas fight over not water, but the politics. But the last one, IS, basically they fall over water. So water is very, very important, especially the fresh water. So you should mention and remember this important word. Why fresh water is very important? Because very, very limited amount. So this table showing total amount of the global waters. So global water is about 1.4 times 10 power 9 cubic kilometers. So huge amount. I cannot imagine. So but huge amount. So in the earth have water. But unfortunately, almost all water is seawater. Seawater percentage is about 97.5%. And this blue color is fresh water. So fresh water is almost basically the glacier or the sea ice. And the other most part is groundwater. So very, very deep groundwater. It's very difficult to use by the human being easy. So very deep groundwater. So this light table showing only the rate in fresh waters. So you can see ice or glacier is about 70%. And the groundwater is 30%. So these two sections about 99.6%. That means almost all fresh water is very difficult to use human being directly. So only the very small amount, like the lake and river water percentage, just 0.3%. So very, very small amount. So if the earth all water is this pet bottle. That means if the global water is 1 bottle of the pet bottle, that means 500 milliliters. How many volumes we can use fresh water? How many? How about? So only one drop. Only one drop is fresh water, lake and rivers. So very small amount is fresh water. So that means fresh water is very important because we cannot drink seawater at all. If we can use or drink seawater, there's no problem. No problem. But unfortunately, we cannot drink or use seawater directly. There are very problems. So fresh water is very, very important resource. But unfortunately, only rainfall can be produce fresh water, but in the natural environment. That also very problems. And unfortunately, annual rainfall amount volumes is only 34,000 cubic kilometers. That is 0.003% of total global water amount. So this indicates if we polluted fresh waters, it's very difficult to renew or remove the pollutant from the waste waters. And human beings, fat sector basically are using the fresh water. So rest of the water that man use, you can see the main part of the fresh water used by human beings is agriculture, irrigation use. That about 65 to 75%. And second one is industrial use, about 20 to 25%. Third one is our daily life, house and regional society use, around 10%. So the agriculture and the irrigation use of the fresh water is largest amount all over the world. So the it's some percentage different country by countries. So this figure showing freshwater use country profiles. So Japan, the color is yellow. I think ちょっとイエローになってるけど、まあイエロー。So yellow color means agriculture widely dominant with significant use by the industrial sector. So how do your mother countries? For example, China is same as Japan. And どの辺がいる? I'm not sure. So where is your mother country?
US.
US. So US is pink. So pink is industrial and agriculture equally dominant. But don't mistake. So basically, agriculture is most used. Okay. 他、誰かいる ?Other mother country? フランス。フランスはここか。こっちだね。So industry widely dominant. But of course I know France is a big agricultural country. Another 何ネパール。ネパールは入ってんのかグリーンだよね。グリーンだが agriculture widely dominant. Yeah. So basically, so a little bit different, but mainly the use is agriculture. Yeah. So I introduce you how the fresh water is very important and precious resource. So this century, 21st century, we sometimes called the century of water because water, especially the fresh water, is very, very important. So now I have a question. How we called last century, 20th century?
Maybe the oil century because of the Cold War and also the war in the east for the oil. And we saw a rise of the oil in like Saudi Arabia.
Yeah. That one. Yeah. Other? Someone called the century of war. Yeah. Someone called century of oil. Someone called century of science and technology. Yeah. So but this centuries, yeah, of course, I think the other called they are named, but someone called the century of water. Yeah, I agree. This call. So now we have the serious water problems confronting human life. So problem is basically the two parts. First one is water shortages. And the second one is water contamination or water pollution. Okay. So the water shortages. So 2 billion people are facing water shortage. And 1 billion people lack access to safe water. Yeah. Water contamination. So 3.6 million people die each year from water-related diseases. 43% of deaths are due to diarrhea. So not safe drinkable water we cannot get so easily. We catch diarrhea. That's very, very problems. And 2.5 billion people lack access to improved sanitation. Yeah, so how we create or how we make safe water, safe drink, not only the drinkable waters, but also safe fresh water. How we make is also very important issue this century's human life. So I showed some data. related water shortage and water pollution or the contamination. So this graph showing total population access to an improved water source. So this color showing the more than 95% access to an improved water source. And so this like as orange color, less than 65%. So unfortunately, many countries people cannot access an improved water source, like as tap water, safe tap water. So this is one big problem. In Japan, yeah, now you live Tsukuba, okay? If you go Hokkaido, if you go Okinawa, and using tap waters, any region in Japan, same water quality, you can use, you can drink anywhere in Japan if you use tap water. That's one of the proud Japanese society systems. This kind of the systems, that means all over the country regions can supply safe tap water systems. Now we have around 200 government or the 200 countries. Only less than 10 countries can support this kind of the system. So no problem. If you go anywhere in Japan, you can find tap water. Doesn't matter. You can drink. You can use. So second graph showing the total population access to sanitation. Sanitation means like as a flushable toilet systems or the sewage treatment systems. Also, many countries still doesn't have enough systems, this sanitation. That means some part of the fresh water contaminant or the polluted by not only the microorganisms, but also sometimes chemicals or the heavy metals. Why I introduce these two informations? Because water quality or the sanitation or safe water is related children death percentage. So this graph, left one, showing percentage of population with access to safe drinking water. So for example, United States, almost 100% can access to safe drinking waters. But unfortunately, like as Cambodia, so less than 20%. Okay. And the right side graph showing death of children under 5 years old. Yeah, so the country can get or to access safe drinking water. Children deaths, very small amount, small numbers. But if many country people cannot access safe drinking water, that case, many children died. So the important point, the government should manage or establish safe drinking water supply systems over the countries. Yeah, easy to say, but doing and establish, making the systems and the buildings, systems, faculties, it's very difficult, I understand. But this is exactly true. The good or safe fresh water, safe drinking water, save children's life. Now, one of the very important point. And now, we have another problem. So this is the spread of cholera, 1950 to 2004. So, at first, cholera is very domestic, regional diseases. Only like the India or the some Southeast Asia countries. But 1960 to 1970, 1970 to 1990, and 1990 to 2004, the existence or the report of the cholera spreading over the world. Why? The two reasons. First one, easily move country to country. Many people move countries. This is the first. And second one, global warming. And like as many people gather urban areas. So, cholera is originally tropical countries' disease. That means cholera microorganisms is basically growing under like the high temperatures, high water temperatures. That means more than 20 degrees Celsius or 25 degrees Celsius. So if cholera transport the other countries, but that countries natural environment condition is cool or cold, basically cholera cannot survive at all, especially the winter seasons. Okay, so the spreading is something that limited. But unfortunately, So global warming. So the average temperature increased. Also the urbanizations. Many people gather cities. The city have the many heat source. And like as a warm, not climate, but warm environment. So now, cholera bacteria can survive even in the winter at like the temperate or the cold regions countries. So this is the two reasons cholera spread over the world. And for example, in Tokyo, so we don't have any cholera patient. That patient basically 1 or 2 times went to abroad, went to tropical countries and back. But recently, some patients never go abroad. They live, they stay in Tokyo, no abroad, but have cholera. So that means cholera bacteria can survive in Tokyo water conditions and can survive even in winter and growing, spreading in the Tokyo water. So that situation, I think, already occurred almost all countries. That one very severe new problems. Other diseases from the mosquito. Yeah, that also now very severe problems and spreading from the tropical country to the more cold countries. That also very severe problems. So, second topics, microorganisms. So I already introduced you how the fresh water is important, precious resource. But water closely related organisms and microorganisms. So, first, this slide is definition of life. What is life? What is organisms? What are different organisms and non-organisms? What are different? For example, bacteria and virus. What point is different? Bacteria and なんだっけ、忘れた。プリオ。What point is different? So, biologists make some rules. How or what is life or the organisms? The first one, having membrane. So it has membrane systems that clearly distinguished the outside from the inside of cell. And the second one, having gene. So it has a potential for self-renewal. And third one is having metabolism. It has a system that takes in substances from the outside and metabolizes them. These three characteristics should have organisms. So, question. How do you think virus is organisms or not organisms? Not organisms. Why? Yeah, that too. So, biologist, basically, virus is not organisms. Yeah, defined virus is not organisms. But for example, food poisoning. So virus is like the same category of the microorganisms. Now, so the basic biological view, point of view. So I think I agree. Virus is not organisms, but some characteristic or categories, including virus, same as other organisms, especially the microorganisms. So today's my class at food poisoning part. I listed up norovirus in same as other microorganisms. So, what is microorganisms? Organisms that can be seen only with aid of the microscope, and that typically consists of only a single cell. One cell, single cells. Microorganisms include bacteria, protozoa, and certain algae and fungi. It may contain a virus. So they are distributed all over the Earth. And second definition. So classification by natural microorganisms. So I think already you learned eukaryotic organisms, also the prokaryotic organisms. So microorganisms contain these two organic systems. So eukaryotic and prokaryotic. Of course, eukaryotic microorganisms organisms consist of a cell or cells in which the genetic material is DNA in the form of chromosomes. This point is very important. What is a eukaryotic organism? So eukaryotic include all living organisms other than the bacteria and archaea. So bacteria and archaea is prokaryotic microorganisms. So what the difference is prokaryotic microorganism doesn't have distinct nucleus. But they have the same as eukaryotic. So membrane nor other specific organisms, including the organisms is only the two systems. One is a eukaryote, and second is prokaryote. And almost all as organisms is belonging not eukaryotic, but prokaryotic. Because the highest classified level of the organisms is domain. So we have 3 domains. First one is bacteria. Second one is archaea. And third one is eukaryote. So 2 of 3 domains belong prokaryotic microorganisms, bacteria and archaea. Only one domain related eukaryotic organisms, including human beings, including plant, including fungi. Yeah. So in the Earth organisms, mainly it's prokaryotic microorganisms, not us. So characteristics of microorganisms are also very important, not only the microbial ecology, but also food poisoning. So the most important point, fast growth. Yeah, quick growth. So for example, E. coli, one of the fastest dividing or growing microorganisms. Suitable, the best condition for growing. E. coli can divide their cells each 20 minutes. Yeah, but this 20 minutes is not the fastest one. The fastest one is about 8 or 10 minutes. Not E. coli, but other microorganisms, if they live in the best conditions. So they can divide about 8 to 10 minutes. But anyway, so one division in 20 minutes, 3 division in 1 hour. So the 6 divided 2 hours. So that after 2 hours, 1 to 64 cells. So how about after 8 hours? So after 8 hours, 24 divide growing. So that means 2.7 times 10 power 7. So please calculate after 3 days. After 3 days, yeah, basically all the Earth's surface is E. coli. So, but that situation doesn't occur. Why? That situation doesn't occur. All the Earth's surface is E. coli. That situation doesn't occur. Why?
Because some environment is not suitable for them to be.
Yeah, that's one reason. But main reason is, yeah, fast grow and fast die. Yeah. So many growth, but many die. This. So no situations or the Earth surface is equalized. And second important characteristic is decompose various substances. So I think basically you can understand, yeah, organic matters, but also like as a gas, such as nitrogen or methane, or some other gas, microorganisms can eat, can decompose. And also, microorganisms can decompose or eat synthetic chemicals. Not natural, but artificial synthetic chemical. Some microorganisms can decompose. That characteristics is very, very important sometimes. If microorganism doesn't have these characteristics, human being surrounding many like other harmful or the poisonous chemicals, not only the air, atmosphere, but also the water, but also the soils condition, environment. A third important characteristics is live in various environments. So they can live soil, fresh water, seawater, and hot springs, and seafloor, and permafrost, and crust, even in the crust. Do you know the highest temperature can microorganisms grow? (100°C or more? How do you think? So now, reported highest temperature can grow the microorganism is about 130 to 40 degrees Celsius. I think you have a question because under 1 atmosphere pressure, the water boiled at 100 degrees Celsius. So I told you, so the highest temperature is 130 to 40 degrees Celsius. Because that kind of bacteria live in deep sea. So having the high pressures and the high pressures, for example, 1,000 meters deep, having the 100 atmospheric pressures. That environment, the water doesn't boil at 100 degrees Celsius. Around 200 to 300 degrees Celsius, the water can boil. So deep sea microorganisms, like as hot springs, hydrothermal vent, microorganisms can grow under more than 100 degrees Celsius. And also the many microorganisms live in crust. So growth characteristics of bacteria, I already told you. So E. coli is one of the highest high speed dividing microorganisms, but this Vibrio species is fastest. So only the 10 minutes. So I calculated. So if there doesn't die at all, so after like the 2 hours, E. coli is a 64 cells, and the Vibrio species 4092 cells. And after 4 hours, so more than 16 million cells. So this characteristics is very important for the environment. But also, we should understand bacteria, microorganisms easily grows rapidly in the food. So food poisoning, if you consider food poisoning, this characteristics doesn't forget. So if you bought like as a rice bowl in the summer seasons, and then that rice bowl keep in the car about 3 hours or 4 hours, just from the morning to the noon or something. What happened? So if the food poisoning bacteria easily grow, that case is more than 10,000 or the 1 million cells in one rice bowl. That easily you can take food poison. So doesn't forget. So bacteria or the microorganisms can grow fast. So what is most important role of the microorganisms? I think decomposition. So they decompose not only organic matter, but also some chemicals or some gas. So if this decomposition doesn't occur at all, how the Earth's surface occur? Already died this biomass over the atmospheric regions. 10 kilometers, I'm not sure, 10 kilometers or 20 kilometers. All the this distance is this organic matters. But microorganisms every day, every minute, eat or decompose organic matters. And finally, organic matter change to the inorganic matters, such as nitrogen gas, or the phosphate, or some other metals, ion, or some things. So the biomass decreasing. So that systems is very useful and sustainable. Maintain the terrestrial or the land of the or the sea in the earth. So the ecological system on the Earth is established only when this microorganisms works. So today's final section, I told you food poisoning. That like the worst, not good phase of the microorganisms. But basically, microorganisms just eat or just decompose organic matters. Don't forget, please remember this important. So, classification of living things in ecosystems. I think already you learned. So, producer is autotroph. So, like the plant, phytoplankton, algae, or some things. So, an organism capable of synthesizing its own food from inorganic substances using light or chemical energies. And consumer is heterotroph. So an organism that cannot synthesize its own food and it's dependent upon complex organic substances for nutrition. And also the decomposer. Decomposer also heterotroph. That including bacteria and fungi. So any organism in a community, such as a bacteria and fungus, that break down these tissues and bring the constituents to be recycled to the environment. So how many cells, microorganisms living in nature? So this is the average values. So such as soil, cell density around 10 power 3 to 10 power 8 per 1 gram soil. And seawater, 10 power 3 to 10 power 6 cells per 1 milliliter of seawater. Now air, even in the air, 10 power 2 to 10 power 5 cells per cubic meter. So that means this class, including at least 1 million or 10 million cells, this class having the microorganisms. And food, autoclaved, thrives, case 0 to the 10 power 7 cells per 1 gram food. And I mentioned, like the sashimi also include having 10 power 2 to 10 power 6 cells. And spice, you can remember, spice have so many microorganisms. 10 power 2 to 10 power 7. So please don't forget, spice have microorganisms. Sashimi or the vegetables also have microorganisms. So that means almost all material or the food surface have or live some microorganisms. It's very difficult to remove, wash out all the microorganisms from the food surface. So, Parman's rules. So microorganisms live or survive any field on the earth and can grow anywhere, everywhere. So microorganism is always right. Microorganism is your friend. Microorganism is a sensitive partner. There are no stupid microorganisms. Microorganisms can do anything, will do anything. Even in the synthetic chemical, they can decompose in near future. So microorganisms are smarter than chemists. Microorganisms are wiser than engineers. Microorganisms are more energetic than chemists or engineers. If you take care of your microbial friends, they will take care of your future, and you will live happily ever after. I think that's true. Also, the Carl Woods, he is a very famous microbiologist. He mentions, so it is essential that microbiology be perceived and practiced in a way consistent with the natural order of things. Microbes are the base for and sustain all other life on this planet. So let us strongly agree. Oh. So I think this slide you already got. So ecology, that means the interconnected web of life. And environment or ecological microbiology means study of microbes in their natural habitat. Applied microbiology, study of practical use of microbes in food processing, industrial production, and biotechnologies. And my major, so microbial ecology, is study that interaction between microbes and their environment, involving living and non-living components. That's so different definitions. So please remember, so this environment or ecological microbiology and applied microbiology and microbial ecology. I think this slide you can get from the Manaba. Yeah. So before the rest 15 minutes, so I introduce some of the features of the microorganisms. So closely related environment. So the most important environment factor for microbial growth is temperature. Temperature is most important. And so optimum temperature for growth depends on the bacterial species. And you should remember, so there are some classification. So first one, the optimum temperature are around 20 degrees Celsius, a little bit low temperatures. We called cyclophilic bacteria. And about 35 degrees Celsius, that closely related to human diseases, because human average temperature, body temperature is around 35 to 37. So mainly closely related to this classification organism. So we called mesophilic bacteria. And more high temperatures, around 55 degrees Celsius is the optimum. We called thermophilic bacteria. And someone is around 70 or 80 degrees Celsius. That case we called hyperthermophilic bacteria. But anyway, so we classified 3 different optimum temperature range. So cyclophilic, mesophilic, and thermophilic. And food poisoning closely related mesophilic bacteria. And pathogen agent humans are mostly mesophilic bacteria. Because human body temperature about 35 or 37 degrees Celsius. The optimum growth temperature of fungi and yeast is around 25 degrees Celsius. So a little bit low than mesophilic bacteria. And the minimum growth temperature of microorganisms in food is about minus 11 degrees Celsius for bacteria and fungi, and minus 10 degrees Celsius for yeast. That are very important information. So if you frozen the food about minus 10 degrees Celsius, that means some bacteria or some yeast can grow, doesn't rest or doesn't sleep, can grow. Most human pathogens are mesophilic bacteria and little growth at temperature below 5 degrees. Okay, so if you keep food like as a safety, so you should refrigerator temperature setting below 5 degrees Celsius. I strongly recommend 3 or 2 degrees Celsius. Maximum growth temperature is about 50 degrees Celsius for bacteria, about 60 degrees Celsius for fungi and yeast. Bacteria die slowly in the frozen state, but they can survive for quite a long time. So don't mistake. So if you froze food, all the bacteria doesn't die. Just keep like as a sleeping stage. So don't forget. And second, not second, but the most other important environment factor is pH. So generally, the optimum growth pH of bacteria is about around 6.5 to 8. Bacteria hard to grow when pH falls below 4.5. So that's acidic condition. So acidic condition is one of the best keeping food. There are some exceptions. Yeah, exception already have. So that can grow even the acidic condition, such as lactic acid bacteria. Other can at alkalic conditions, 8 to 9 pH. The optimum growth pH, fungi and yeast, is 5.0 to 6.0. So a little bit acidic condition than bacteria. The growth of microorganisms is strongly affected by the pH of the medium. So if you treat microorganisms, you should check pH any times. Each microorganism has an optimal pH. So bacteria, Actinomyces, and so on, about 6.5 to 8.0, so natural. And below pH 5, they cannot grow. Fungi and yeast is optimum pH is a little bit acidic condition, 4.0 to 5.0. So different. So bacteria and fungi and yeast is different. So also the expression. Some plasma can grow below the pH 1. So strong acid condition, but they can grow. Alkalophilic bacteria, the optimal pH around 10. So completely different. どこまでやっもうちょっとだな。あと2、3枚、2 or 3 slides, and then rest. So, other important environment factor is oxygen. So, requirement of oxygen. Human beings, yeah, of course, we should require oxygen. But microorganisms basically doesn't require oxygen. I think half of the microorganisms no need existence of the oxygen. So they characterized like the 1, 2, 3, 4 categories. The first one is of course aerobic bacteria, same as a human being. So cannot grow without oxygen. And the second category is facultative anaerobic bacteria. So can grow even with or without oxygen. And third category is strictly anaerobic bacteria. So can grow only when there is no oxygen or only a small amount of oxygen exists. So there doesn't require oxygen at all. And fourth one is microaerophilic bacteria. So they can grow when oxygen is present only a little. That only a little means about like the several percent, 1% oxygen or 2% oxygen, not 20% oxygen. So we can categorize microorganisms these 4 different by the how they sensitive oxygen. And the other environment factors is osmotic pressure. So for the growth of microorganisms, specific constant internal osmotic pressure is required for each microorganism. So the osmotic pressure resistance of microorganisms, fungi, yeast, then bacteria. So fungi is tolerant to the osmotic pressures. So hyperosmotic bacteria required high osmotic pressure for growth, such as halobacteria. That also the important. Why I introduce this kind of the environment factors? Because later class, food poisoning. That means how we keep save food. So that case, we should consider this kind of the environment factors. That very important. And also the pressure. So general microbial growth, atmospheric pressure is appropriate. 1 atmosphere pressure. But someone like pressures, like as a biophilic bacteria, they require more than 100 atmosphere pressures. And 100 atmosphere pressure, they can grow. But if the 1 atmosphere pressure, they cannot grow. So this kind of bacteria we call biophilics. Other biotolerant bacteria, they can survive. They can bear under high pressures, but they like 1 atmosphere pressure. So that's different. Biophilic bacteria, they like pressure. Biotolerant bacteria, they don't like high pressure, but they can grow or they can live under high pressure. That's the difference. So in the deep sea, not only biophilic bacteria, but also the biotolerant bacteria live and grow. If you want to more information, please check our university website. So last March, my laboratory's one paper is introduced at the university homepage, closely related this biophilic and biotolerant bacteria in the deep sea regions. So, last slide. So I already introduced autotrophic and heterotrophic, but classify 4. So first one is photoautotrophic. So energy source is light, and the main carbon source is CO2. This is the first category. And second category is photoheterotrophic. Energy source is light, but main carbon source is organic compound. And the third one is chemoautotrophic. So energy source is chemical substance, and the main carbon source is CO2. And chemoheterotrophic, including human being. So energy source is chemical substance, and the main carbon source is organic compound. So classification of microorganisms based on energy and carbon source, we can classify 4 categories. Okay. だいぶやったな。So, let's rest 15 minutes.
I need to say I did this one.
Yeah, sure. I'll type it
This
up.
one.
Yeah, I saw that
Oh
one.
my god, thank
You
you.
do that. Oh, is that?
It's high.
Oh, yeah.
Oh, I did. And this one is. And
I sometimes marvel like.
it's fine.
You were drawing.
I love you. Oh, yeah, yeah.
I just missed this one section. Is this like this?
Yeah.
Weak to strong?
こっち
Weak to strong?
レジスタンス、ハイレジスタンス、
Hi, yeah.
パンジャ。
Hold on. This is greater than this. This is greater than this.
あ、いやいやいや。
Okay.
That all closely related to data slide. This one. I think you can get this PDF file
Yeah, we
and
can.
to the Manaba, I think.
But there's like missing slides.
What really? Yeah. Someone I skipped because some of the graph and some of the different required. So
Yeah, I need the second page of the temperature. I know.
I'm like, the second page of temperature and second page of pH too
Yeah.
was gone. So
And that's kind of important.
so this
wait, aren't these related? No, not at all.
not so
Really?
different. Inside the pressure and this is the outside pressure.
This one is like between the membrane.
Yeah.
Yeah, right.
Inside the membrane
Yeah,
and
yeah.
outside the membrane. But
This is just the outside
this
pressure.
is so inside.
No.
Oh, this is outside. But I was wondering if the pressure of the outside suddenly changed.
No, they're just such as a deep sea. If the 1,000 meter depth surrounding pressure is 100, not one.
So this one is more like micro and this
Yeah,
macro.
yeah. That's sensitive.
I remember just being so sick, I couldn't and being very busy. And then I think after that, maybe just like a handful of.
So adding the high pressure sometimes stratify,
Do you have an email address?
killing
Or-
the bacteria.
I don't have my phone.
But unfortunately, if adding the high pressure, temperature also increase. So So the food saving. Some company want to adding the high pressure and keeping the safe food. But unfortunately, increasing the temperature, so food taste is changing.
I was the week before. I'm looking at that. No, it's a woman. You were there, yeah. Oh. I was laughing. I was laughing my ass off.
Read through all her note, like slides, like you have your slide.
She was talking about ice cream contamination for a while. And then I was just exhausted. It was like, went too long.
That was great. Super good. Us students get over this is the reason for that.
And then what was Ramesh was here, and they left her,
Yeah, no, yeah, we left together.
Ramesh.
Yeah. I was with them. Like, it's just. Okay, thanks. Thank you on this.
Okay. I'll look at it.
Have you visited the big place?
Oh, no, I did.
I also share that with you. I just remember you.
Yeah. I have to find it, mine is kind of far away.
Yeah.
More like, I forgot. Yeah. So medication.
そこは今から来てもダメだよ。ダメだよ。まあ、半分以上終わってるじゃないか、今日。聞くのはいいけど、出席はダメだ。
No. Hopefully I won't be sure back. I have no idea though. Do you live on it? Yeah, I might move. I'm not sure. In Global Village.
Oh, yeah. Yeah, but I still have to read it. They don't, they think I still live there. I'm kind of like, I left almost there.
Yeah.
It's the place. Those people, they hate interaction. Like, I like how they but then they want nothing to do.
In the front desk.
Oh,
yeah.
Yeah, they're very shy, they, like, to the point where I feel uncomfortable living in the same, like, under the same roof.
Yeah. I've heard a lot of stories about.
저 착색이 안 돼. 뭐 하냐,
It's
이거.
annoying when they're like really bothering you all the time, but it's also annoying when they don't bother you at all.
Right.
Like, oh, like, they'll, like, I don't know what they're doing. To see. I mean,
That's what it's like. Yeah, I realize that is most fast.
Oh, wait. Yeah, I want to. Another class.
Talking about Global Village.
Oh, yeah.
Just the people there are very.
Yeah, they're really amazing. They try to like listen to like the movement, like all the movement, and then if you're out in the like community space like kitchen, and You're using the shower or anything. They will not come out. As soon as I went out, they literally do that. They will like open once they hear you're in the room, and then they will like immediately like go back once you're out. Yeah, I feel rejected. Yeah, so uncomfortable.
You live in Global Village too?
Yeah. I'm just sure you're shy to me. So I can't do that. So I'll rush into my room because I'm too shy. I will slam my
We introduce ourselves, right? And then they're like, oh, I'm sitting in the room. And then they suddenly just like, yeah,
And only Japanese girl literally after we are like 4 of the guys are after we all
that's why I don't like that.
so you
I still have a room, but they think I'm like because they never see me. I didn't like it. Yeah, 90 minutes.
さて、一人帰ってきてないけど、そろそろ15分だね。
You live in Global Village too? Which building?
Can we start class?
Yes, please.
Okay. So, okay, main topic, food poisoning. So already I introduced you the water and microorganisms. And third topic is food poisoning. But at first, so the influence of microorganisms on human activities. So many, so agriculture, disease, energy, environment, and biotechnologies. But today, only focus on the food. So food preservation and fermented food and food additive and putrefaction or food poisoning. So fermented food and putrefaction is closely related. So I will later introduce. So food and microorganisms. Microorganisms deeply related to food. Bacteria, yeast, fungi, and virus. And microorganisms important in food hygiene, especially bacteria and virus is very important for food hygiene. So what is inherent? Fermentation and putrefaction. So in a state in which microorganisms are decomposed for food components. So fermentation defined. So alcoholic fermentation is a type of anaerobic respiration in which sugar is changed into alcohol and carbon dioxide. And putrefaction, protein, amino acid, and so on are decomposed to produce unpleasant odors such as hydrogen sulfide and ammonia. However, it is sometimes called decay even in the decomposed state of sugar it is not distinguished by difference of raw materials or metabolic products. So, important point, the most clear revision way is fermentation is to produce useful food for people, human beings. And decomposition is to be decomposed into food that people cannot eat. So basically, it is used by human value standards. So fermentation, if we use, so basically, that we can eat. Decomposition, we cannot eat. So putrefaction. So fermented food, I think you know and understand, and you eat every day. So for example, yogurt, cheese, and Japanese natto, and soy sauce, and miso. So this natto, soy sauce, miso is a Japanese traditional fermented food. So Japanese fermented food, so many, like the sake, vinegar, rice bran pickles. There are many fermented food produced in Japan. So fermentation and brewing science developed in Japan. So we have many like other sake brewery and miso and soy sauce companies. And so I think you are already over 20 old, so you can drink alcohol. so difference in fermentation process of 3 great brewed liquor. So wine, beer, and Japanese sake. So different. So wine is very simple, easy. So single fermentation. So glucose and wine yeast to alcohol. So that means the important source is grape. Grape, like the species or the grape growing place area is very, very important. The taste depends on basically the grape and some yeast species. Second one, beer is a little bit complex. So single line, multiple fermentation. So starch, heat starch, and plus malt, then maltose, and plus beer yeast. Finally, alcohol, beer. So a little bit complex. But completely different is Japanese sake. So Japanese sake is a parallel multiple fermentation. So starch, rice starch, plus koji, so the microorganisms, fungi, and then making the glucose, and adding sake yeast, then making alcohol. So Japanese sake use different two type microorganisms, and also having the other lactobacillus, acidic microorganisms. So basically very difficult to manage and keeping the good environment conditions. So, because so wine, beer, and Japanese sake is different fermentation steps. So each one requires like the good materials and good like the microorganisms. So alternation of food by microorganisms, related food poisoning. So perishable food. So the most superior microorganisms in the food preferentially grow and form a unique microbial flora. The food contains nutrients necessary for the growth of microorganisms. Basically, food is organic matter. So basically, the microorganism can grow on food. That's true. But in the natural environment, the first, like the attached microorganisms, is not closely related food poisoning or something. First attaching and like the eating or the decomposing the food, and then making or producing second materials, and using that second materials, and that like other microorganisms growing on the food, and then shift it. Finally, food poisoning occurred. So, leaving the food at room temperature, coexisting bacteria with food, and secondary attached microorganisms grow. And food loss its original characters, such as the nutrition, appearance, flavor, and texture, and contaminated with microbial metabolites, such as toxins produced in the food. So this is like the purification steps. So entry pathway of microorganisms into food. So I will already introduced you. So everywhere microorganisms exist, even in the atmosphere. So fungi and bacteria are everywhere. So attached to objects and carried. They are carried on the air. So in the case of fungi, it is carried in the state of spores, adhered to substances, grows mycelium, germinate, and became fungus. For example, average 80 spores per cubic meters in the open air. So many fungi spores surrounding anywhere. So hygiene control require not only sanitary check, sterilization, cleaning of the object itself, but also microorganisms in the space. I think you already learned HACCP systems. For that case is required. So this all the steps, this all the positions. So consider about food. We should environment conditions for microorganisms. So, but I already introduced, told you, first class. So, important point, I factor environment, temperature, especially the moderate temperature, 10 to 35 degrees Celsius. And second one is nutrients, organic and inorganic substances. Dust, that of organic substance are also nutrients. And the third one, moisture, humidity. Humidity also required for microbial growth. If completely dry conditions, most microorganisms cannot grow. So the moderate or the high humidity required. And fourth one is oxygen, but except anaerobic bacteria. Anaerobic bacteria doesn't require oxygen at all. Unfortunately, not only like as anaerobic bacteria, but also anaerobic bacteria cause food poisoning. So it's very difficult to like as manage the food conditions and oxic, so both several bacteria can grow. So putrefaction and spoilage, what are different? So generally, a phenomenon in which a food is altered by microorganisms to lose an edible part. There is a following change when it became putrescent: smell, taste change, gas produce, sticky past. So, in a restricted sense, putrefaction means protein decomposition process in food. So protein decomposition process called putrefaction. And the spoilage is carbohydrate and fat decomposed by microorganisms. So carbohydrate and fat decomposition process called spoilage. So this is the definition. So putrefaction means a continuous metabolic process leading to the final product by various intermediates. So early stage, so characteristics of food, composition, pH, moisture, sugar, sugar content, salinity, redox potentials, and storage conditions, temperature, humidity, surrounding gas components, and its concentration. So not only one species microorganisms works, but firstly optimal microorganisms for the environment proliferate predominantly, whereby food compositions and food environment change. And then, next, different microorganisms growing. So this step circled, and then finally putrefaction. So that means not only one species is caused by the putrefaction. So many species, many different species related food putrefactions. Don't forget, because surrounding the air include having many kinds of microorganisms, and they easily attach. And if the environment is good, was comfortable, easy growing, that situation is called putrefaction. So, how we preserve food? So, putrefaction of food is caused by growth of microorganisms in food. Yeah, that's true. So, therefore, the principle of food preservation or storage is to protect food from contamination of microorganisms and to inhibit the growth of microorganisms. So, to protect food from microorganisms and inhibit microbial growth in our own food is very important for preservation of food. So method of storage can be roughly divided to the following two. So first one is keep food at low temperature or freeze dry state, add salt or sugar, acid, or preservative to suppress the growth of microorganisms in food. This is the first choice. Second choice is inactive microorganisms in food by heating or radiation or irradiation with ultraviolet light or disinfection and so on, and also seal them in containers and prevent secondary contamination from the outside. So completely divide contamination or the attached microorganisms after like as a killing all the microorganisms in the food. So only the two ways we keep the food safely. So we have many strategies or the method to prevent food. So first one is thermal sterilization. Second one is ultraviolet sterilization. And third one is eradication of bacteria. Fourth one is chemical sterilization. And fifth one is refrigeration or freezing. And sixth one is salting or sugaring. And seventh one is drying. Eighth one is vacuum packaging. And the ninth one is smoked or pickling in vinegars. Yeah, we have more. This is just very famous or the typical method for prevent food putrefaction. I think you know other method to prevent food putrefaction. But this 9-way method is very famous and typical ways to prevent food. Why we remove water or the humidity? Because most bacteria related putrefactions or the food poisoning required like the moisture or the active water activities. So already we have the information of the moisture and water activities. So water activities we call AWs. So water takes two forms in food. This point is very important. So one is bound water combined with protein and carbohydrate. So water combined some other chemicals, substance. And the other is free water. The proportion of free water. So combined water doesn't matter because it's difficult to use microorganisms directly. The important is free water in the food. So the proportion of free water in food is represented by AW, water activities. Microorganisms can only use free water. The AW of the food is lowered by drying, decreasing with the addition of sugar or salt or soak in vinegar. So removing free water is very important way to preserve food. So in general, bacterial growth in food with high AW. Yeast grow in food with relatively low AW. Fungi grow in food with low AWs. This is the table graph. So left side growth permissible and right side food. And this bar showing the AWs. AW is from the, I think, 0 to the 1. So 1.0 is so raw meat, fresh fish, and vegetables. And for example, less than the 0.8, so soy sausage, miso, jam, and honey. And this side showing what kind of microorganism can grow. So the high AWs, so bacteria, and 0.9 around general bacteria or the general yeast, and 0.8 so general fungi. And so halobacteria, they like salt condition, high salt condition. That kind of specific bacteria can grow even under the 0.8 AW condition. And lower than the 0.7, so very specific, special bacteria, not bacteria, but fungi or the yeast only can growing. So we consider how remove fresh water. That one very important sense for food preserving. So please remember AWs. And AW means the proportion of free water in food. So putrefaction and food poisoning. So unfortunately, preservation and food poisoning occur. So in general, even if you eat rotten food, food poisoning often does not occur. Yeah, food poisoning means some bacteria that easily cause poisoning for humans. So basically, normal bacteria doesn't have poisoning, just putrefaction. Not good taste, not good smells. But sometimes we got food poisoning. So some specific bacteria or some specific virus or some specific chemicals, including in having in the food. So the important point is here, don't eat purified food. How you recognize, how you check, how you understand, yeah, this food cannot eat. So the most important is using your eye, your nose, and your fingers. That's three parts, very, very important. Checking and deciding, yeah, this food can eat or not. So that's very important. So food poisoning definition is acute illness, typically characterized by gastrointestinal inflammation, vomiting, and diarrhea, caused by food that is either naturally poisonous or contaminated by pathogenic bacteria. So different. One is naturally poisonous, and the other is pathogenic bacteria. So food poisoning is different caused. So depending on its causative substances, it's classified as microbial food poisoning. Second one is natural poisoning. And natural poisoning means chemical substances and other unknown causing. But in Japan, almost all food poisoning caused by microorganisms. Yeah, not like as a natural poison and chemical substances. But some death case, human being died, 2 or 3 persons per year, every year in Japan, basically by chemical substances, natural chemical substances. And microbial food poisoning can be divided into bacterial food poisoning and viral food poisoning. Bacterial food poisoning is classified into infective types and toxic type. So infectious type cause clinical symptom by causing the ingesting the bacteria attached and growth in the food. And toxic type show clinical symptom by ingesting toxin, producing coated bacteria in growing food. So, infectious type, that case, we should eat some amount of caused bacteria, food poisoning bacteria, directly. Some cell numbers. If less than the level, we don't cause food poisoning. But toxin type, very dangerous. Very, very dangerous. If very small cell numbers of food poisoning bacteria, but that bacteria make toxin in the food and eat, easily die. Easily die. So we should care these two types. And this is some information in Japanese food poisoning incident. So this is the incident case. So from the 0 to the 1,800. And this is the year. This is a Japanese Nengo. So this H16 is 2004. And R4 means 2022. Okay. And this red bar graph showing incident case. And this blue line showing the incident patient numbers. So you can see in Japan, so the around 2000 to 2010, so incident is almost stable, about 1,400 per year. And incident patient numbers is about 25,000 patients per year. But recent 5 years to the 10 years, decreasing the patient numbers. And incident numbers also decreasing. This is the real situation in Japan. And this is the each month incident numbers. So this one is the incident case, and this one is the patient numbers. And sorry, this is Japanese, but this is 1月 means January, and 12月 means December. And this bar showing the 2020 is red, and green is the 2021, and blue one is the 2022. So, what to indicate from this graph? In Japan, food poisoning occurred throughout the year. There are no seasonal change or the seasonal increasing or decreasing. In your sense, food poisonings mainly occur warm or hot seasons. But that's not true. Now, basically, food poisoning occurred throughout the year. Not only the warm and hot seasons, but also even in the winter seasons, food poisoning occurs. That is very important information. And of course, the patient number is a little bit different. If some big accident occurred by the norovirus or some things, that case is patient number jumping up. But basically, of course, almost the same patient numbers throughout the years. That's the real situation. And this is the monthly what reason or the fact the cause, like from by the bacteria or the virus or the parasite or the chemicals or the plant natural toxin or the animal natural toxin or the others. And this is years 2019, and this is 1月 means January to the December. So you can see in Japan. So almost all main percentage of the food poisoning by basically the blue bar. Blue bar is bacteria. And sometimes main is red bar. So red bar is virus. This is norovirus. So in Japan, recently, bacteria and virus is the two highest reasons of the food poisoning. So these two is main. And more detail. What kind of the bacteria or what kind of the virus? So you can see. So this is the H. ここは R の R4 means 2022. So in Japan, about 20 years, the highest, the main food poisoning caused by this orange. This orange is Campylobacter. Yeah, Campylobacter is the most the main reason for food poisoning. And also, second one, or sometimes first one, is this blue one. This blue one is norovirus. And then, very recently, increasing rapid one, this pink lines showing anisakis. Yeah, this three is the main food poisoning in Japan. So please remember this situation. I'm not sure in your mother countries. Yeah, I think it will be different. But in Japan, so basically Campylobacter and norovirus, and recently increasing the anisakis. This three is top three food poisoning in the years in Japan. So I already introduced you. So food poisoning occurs even in winters. So don't forget, food poisoning occurs only in warm or the hot seasons, but also in the winters, cold seasons. Yeah, of course, cold seasons, basically microorganism growth is not so active. But unfortunately, such as the norovirus or some things, doesn't matter the low temperature. And also if the keeping food in the room temperature, that means that 20 to 25 degrees Celsius. That condition doesn't matter for the microorganisms. Very like as a comfortable, yeah, welcome environment for growing. So even in winters, food poisoning occurred because microorganisms can grow or easily grow. And if you they have the several hours, 3 or 4 hours, no problem, growing and dividing cells. So that's the true situation, food poisoning. So keeping, conserve food under the low temperatures, or the removing free waters. That's very important sense. So also we understand minimum infectious cell dose. So for example, Bacillus dysentery. So minimum infection cell dose, 10 powers 1 to 10 powers 5 cells. If you take, you can take. And for example, so Campylobacter, the most highest incident in Japan. So Campylobacter, less than 10 powers 3, less than 1,000 cells. If you take, you can take food poisoning. So that's very severe problem. So small numbers take, but easily have the food poisoning. And the more severe one is listeria, or どれだっけな? For example, yeah, pathogenic E. coli, O157, very famous pathogenic E. coli in Japan. Some people died 10 or 20 years ago. Yeah. So that one only 10 power 1 to 10 power 3. That means only 10 cells you take. That case, sometimes you get food poisoning. So the important sense is not growth this kind of the food poisoning bacteria in the food. That's one very important sense. So how we protect growth, this kind of bacteria? So keeping low temperature or some heating or something and died, and then protect attached other bacteria. So that kind of the protect, preserve, is very, very important because very small cell numbers growing in the food, we can take food poisoning. And also, we should know, so death temperature or time and the minimum growth temperature of typical food poisoning bacteria. So Vibrio or the Salmonella. So you can see above 65 degrees Celsius to the 100 degrees Celsius, and more than 1 minute required killing this kind of the bacteria. So I strongly recommend you. So more than 70 degrees Celsius or 75 degrees Celsius, and at least 3 or 4 minutes heating required do before eating. Yeah. are very important. Yeah, of course, someone, like as a spore, it's impossible to kill it heating so long period. Yeah, but this is very unusual. So normally you should add more 70 degrees Celsius and more 3 or 4 minutes heating. That's very important. And minimum gross temperatures. So you can see, so less than 10 degrees Celsius. But I strongly recommend you, I already told you, so around 3 or 2 degrees Celsius is better storage temperatures for food. If you don't want to get food poison or food putrefaction. So I introduced some of the food poisoning bacteria, microorganisms, so Campylobacter. So symptom is diarrhea, fever, abdominal pain, and the incubation period 2 to 7 days. And the main cause food, chicken. So should be careful if you eat chicken. And norovirus. So at first, in Japan, we very strongly care the oysters. Oyster accumulate norovirus. But recently, not only norovirus, oysters, but also many, even in the human to humans, easily take norovirus. So that are very problems. So if the one incident of the norovirus, food poisoning occurred, patient number increasing. Sometimes more than 1,000 people. Get diarrhea or something. So it does not contact with the infected persons, stool or vomit. That norovirus case, very important point. So, 3 principles of food poisoning preservation. Every point I already told you, but list it down again. So first one is don't attach pathogens. So microorganisms attached to raw meat and fish may contaminate other foods by your fingers or cooking equipment and cause food poisoning. So keep finger and cooking tools are constantly clean. Try not to spread pollution. And second one, don't increase the number of pathogens. So many microorganisms grow over time as bad temperature control. So eat cooked food as soon as possible. And don't leave it for a long time. That's also very important. So keep food refrigerated or frozen. So when keeping food warm, it is recommended that the temperature is more 65 degrees or higher. And third point is kill pathogens. So most microorganisms are vulnerable to heat. So it's also effective to disinfect dishes and cooking equipment, sinks refrigerators with hot water or chlorine bleach, etc. So don't attach pathogens. Don't attach. Don't increase them. And kill pathogens. That's a very important 3 points. So, 結構早く終わったな。So this is the almost final slide. So now, our environment is not good, I think. So we should consider not only the environment, of course, but also the energy materials, and also the economies. So this kind of the 3 struggles, problems, relationship, we called trilemma. So if this trilemma relationship is not good, so that case is many problems happened or occurred. Now global situations such as garbage trash, air pollution, extreme weather, ozone depletion, or so on. So we should find out answers. But unfortunately, so trilemma problem is having the 3 parameters. So that means it's impossible to get best answer, the best answer. Impossible. So how we do is we should get better answer. That kind of sense is very important. And now I told food. So this trilemma relationship include export, input, water, and food is also very important for our life. So please don't remember, so this kind of the trilemma problems, and also water and food is also important point in our life. Okay, that's all. My slide. ちょっと早く終わるけど、まあいいんじゃない? So, my slide is finished. Taiwan side, do you have any question or comment? Okay.
We have no questions. Thank you.
Okay, thank you. So today's class is finished. Thank you. じゃあ終わります。そことそこは出席はないからな。これ切っていいんかな。